Hello, I'm just testing if everyone is able to hear me. Hello? Testing one, two, three. Okay. Was that in the stream?
Did you hear me at an appropriate volume, or was it still really quiet?
No, I heard you fine. I'm just gonna test it again. You can start now.
Okay. Hello, testing one, two, three. Just getting a few things smoothed out. Really quiet.
No, I heard you fine. I'm just gonna test it again. You can start now.
Okay. Hello, can you hear me? One, two, three. Getting a few testing. It is 9:08 p.m. Just sorting out some small things.
Okay, hello everyone. Welcome to our Starry Nights for the first Starry Nights for July 2021. My name is Rohit, and I'm joined with my co-host Sarah. And before I start, I'm going to pass it over to Sarah as well in a moment, but just give you a little bit of an intro on myself and sort of my history with SFU Starry Nights. So I've been part of the SFU Starry Nights since 2009, and thinking back to it, that's quite some time ago now. So since we first started with the international, we first started in 2009 with Astronomy Day, I believe. That was the first one we had at SFU, and that sort of continued on. And now we have an observatory set up, and we're doing these virtual streams as opposed to in person due to the pandemic. So I'm really excited to be here and looking forward to a great night. And I'll pass it over to my co host, Sarah.
Hello, everybody. Thanks for joining us tonight. We understand it gets a little bit tricky or peculiar doing Starry Nights over the internet, but we appreciate all of you honoring us with your presence here online. We're really hoping that in the fall we'll be able to start doing in-person Starry Nights as SFU moves into in-person activities. But for now, we're going to stick around with our online setup. It's pretty cool though. We can actually control the observatory and the telescope and dome and everything, webcams, from the comfort of our own home. But as Rohit mentioned, my name is Sarah. You might have heard me here before with Matt in the previous months. I've been with the observatory since 2015. So the observatory opened in 2015 April. I've been here since the very beginning. I was an undergrad at the time and totally fell in love with it. I was taking an astronomy course while it was being built, and the prof, Dr. Howard Trottier, had a hunch that I might be keen to help out with the newly built observatory, as he needed more hands on deck to get things moving and running. So as you can tell, I haven't left. So it's really great to be here with all of you. We have a great number of things that we're going to look at tonight. And it's a little bit tricky in the summertime because the sky is still quite bright, even though it's 10 p.m. In the winter months, we are lucky that we get nice dark skies at 7 p.m., but in the summertime it gets a little bit tricky because we're not sure if we can see faint things. So we have our fingers crossed. We've got a nice itinerary for you. So Rohit, what do you think we should start with?
Thanks so much, Sarah. And I just want to let everyone know I'm using a new computer this time around because this unfortunate heat wave that we had last week, it fried up my computer. So bear with me if there are any technical glitches. I'll do my best to avoid as many as I can. Having said that, we're going to start off. Our first object for today is Mars. Now, when Sarah and I we were kind of preparing for tonight, we looked at the objects that we could see, And I really wanted everyone to look at Mars because there's been so many recent activity on the red planet. But it turns out that by the time it gets to good viewing time, as Sarah mentioned, um, Mars is low on the horizon. So the way the observatory is set up at SFU, it looks out, it looks out in a direction, and at that point, Mars is almost at the horizon now. So unfortunately, we won't be able to see it. However, I do want to share something that is something exciting that's happening on the red planet. Um, the first thing I wanted to talk about is uh, the Perseverance, uh, the Perseverance helicopter, sorry, the Ingenuity helicopter that we were able to look at a great video of recently by NASA. Now, um, the rover itself, it landed in February 2021, and there's actually a really nice depiction of what the track of the rover is right now, and also where the helicopter companion is. Now, I'm hoping everyone can see this. So here we're able to see that this is where the rover is. So we started off here and it's traveled up to this point, and this is where the helicopter itself is as well. So this is something that's really exciting. I know when they were doing the videos of the helicopter itself, they had every couple of days they showed the helicopter go from 10 meters, from 10 meters to 50 meters to 100 meters and all of that. So that was really nice to look at. Oh, and you know what? Unfortunately, it looks like my video has skipped, but sorry about that. But yeah, so there was a really nice video of the helicopter itself on the surface, and this is actually not the um, only rover that's on Mars right now. China has actually sent a rover as well on Mars, and they were able to release a video of it as well. The Zhurong Mars rover, and I apologize if I am mispronouncing that, was able to land on Mars as well. And there's also a really nice picture that was obtained by BBC, as where you can see that it's standing next to its landing platform. Now, there are future missions that are on track by China. I know recently it came in the news that they're planning to do a manned mission to Mars, and they're in the preliminary stages of planning everything for this. So it looks like it's an exciting time for some sort of some sort of organism on Mars, because it looks like they're going to get a lot more visitors on there. Um, Now, we, and again, I apologize we weren't able to look at Mars, but uh, if you are able to look at it now, it's a really nice planet to look during the springtime, as it's early in the sky, and if you are able to get to even to a dark spot, sometimes you'll be able to see the polar ice caps as well. Depending on the size of telescope that you may have, you will be able to look at that. I know in the past when we have viewed Mars through our observatory here, we have been able to look at the ice cap. So it's very exciting when that does happen. Um, Having said that, I'm going to pass it over to Sarah and see if she wanted to add anything towards what I just talked about.
Yeah. Two things, if I may add. So Ken, one of our loyal RASC members, for those of you who don't know, RASC stands for the Royal Astronomical Society of Canada, has mentioned that we might actually be able to see Mars right now. I believe he's based at SFU right now. I don't know if we want to try and give that a shot or not. Rohit, what do you think?
You know what? That's more than the confirmation I needed,
Perfect.
and I'm so sorry I did not introduce our moderators or
Yes, that's our second thing.
yes. So we're actually joined by a great group of moderators here. We have Zena from SFU Starry Nights. We also have Haley Miller, who's from Rask as well. I know in the
And
chat.
Zach.
Oh, Zach is here as well. Hello, Zach. And I think I saw Jennifer as well. Jennifer Kirky is here as well. So, hello and welcome, Jennifer. So, I'm so sorry
Thank you.
again. I totally forgot to include them in our welcome note. But let's try to see if we can look at Mars and let's see what happens.
Absolutely. And while Rohit is setting up our view of Mars, as you can see in our screen share, I'll let you know that everybody in our Starry Nights team, so we're all astronomy enthusiasts, and we actually we rotate between who will help out as hosts and who will help out as moderators. We have people who join us as well from RASC, from the Royal Astronomical Society of Canada, and we all get together virtually and help out with running these virtual nights. We each get a turn to pick what we want to see and the things that we want to talk about, so it's always an exciting event. And I believe Haley in the comments mentioned that we'll have a hybrid of events in the fall, and that is correct. So a correction on my previous statement, SFU is hoping to have a hybrid of online and in-person events in the fall, and hopefully that will mean a in-person Starry Nights, though it may be a bit more restrained in order to keep with our safety protocols. But there is light at the end of the tunnel. There is starlight at the end of the tunnel. Looking forward to getting back into the chilly observatory and opening up the dome and checking out the planets. And as we rotate to Mars, I think it's a great time to mention that in this time of year, you can also see Venus right before the sun sets. It's quite a beautiful sight to see out in the west. And the summer is quite a great time to look at planets. You've got Mars right now and Venus right at sunset. And in August, late August, you can actually see Jupiter and Saturn in the early hours of the evening, around 10 o'clock or so, 10:30, 11. So I'm really excited to see Saturn. I know I probably shouldn't name favorites, but Saturn is probably my favorite planet. What's your favorite planet, Rohit?
You know what, Sarah? I think that's a great point that you just mentioned about picking favorites and planets. My this is just sort of a small story, but you know what? I think everyone at the observatory has somehow been connected with Dr. Trottier, and at one point he has. I mean, anyone who is here, we've all been inspired from him, and I mean, he was the individual who inspired me to get my own telescope as well. So the first planet I ever looked through with my own telescope was Jupiter, and this was back in fall of 2009. I'm certain I still have an email somewhere where I told him and I gave him like an observing report of what happened. Um, yeah, so I'm gonna say it's Jupiter just because that was the first planet I looked through my telescope.
Oh, absolutely, absolutely. And you're right. Everybody does have a bit of a connection with Dr. Howard Trottier, the prof who founded the observatory. Him and his brother who founded the observatory at SFU. So it's yeah, everybody's first experience with the telescope and the observatory is quite memorable. I will let you in on a secret. I don't actually have a telescope of my own. I have a pair of really, really strong binoculars, so strong that you actually need to put them on a pair of on a tripod in order to keep it up. It gets a bit heavy to hold, but I don't really have a telescope.
You know what? That's okay. You don't have to have a telescope to practice astronomy. I mean, you can simply start by figuring out the constellations in the night sky, which you just need your naked eye for. And then you can gradually move on to binoculars and then move on to a telescope. And plus, the telescope at the SFU Observatory is a collectively owned. That's the way
Yeah,
I like to think of it. I mean, we're here for the purpose of outreach, and I think it's great that we have something at the center of the city that everyone can have access to at some point. Um,
absolutely.
having said that, I'm just trying to I'm just trying to go through the SkyX, which is a software we use to identify targets we're going to look at, and I don't think we're going to be lucky enough to see Mars. I'm gonna try slewing it, moving the telescope one more time,
Mhm.
and see if we are in that area. But there may be a situation where we may have to move on to something else. What do you think, Sarah?
I think you're right. Unfortunately, I think Mars has just dipped below the surface. Unfortunately, I think Xena mentioned in the comments here, Saturn is her favorite to look at and Earth to live on. I think I have to agree with her. I do really, really enjoy living on Earth, and I think actually that should be everybody's favorite planet is Earth. I know that's Matt's favorite planet, and we should definitely do our best to take care of our planet. I think especially with the recent devastation of the forest fires, it's a reminder that we're in a tricky spot right now.
Yes,
I yeah.
I absolutely agree.
I hope people who are affected by the forest fires and around and their loved ones who may be affected by the forest fires are able to get the support they need to to relocate and find safety. So
Yeah, absolutely.
yes.
I think that's a great point that you mentioned, Sarah. And you know what? Yeah, it doesn't. It's not. It doesn't look like we're gonna get lucky on that part. So I'm just. I think perhaps we should move on and find a different
Okay.
target, and then we'll talk a bit more about that. Um, so, Sarah, did you have a target that you had in mind that you want everyone to take a look at?
Yeah, absolutely. Let's. One of my favorite things to look at is North Star, so Polaris. For those of you who may not know, I'm a scout at heart, so I've been a part of the scouting community for a very long time, since the age of 6. And one of the things that we always do is we learn some key constellations and to find some important stars, specifically Polaris. And the reason why Polaris is so important, and you may all know this already, is that it's the North Star. And it helps guide you in your direction. So, because the Earth is tilted, we don't rotate perfectly straight up and down. We actually have a bit of a tilt. We actually point towards close to Polaris. We just coincidentally happen to have a star close to our point of rotation, and everything else appears to rotate around it as the Earth continues with its 24-hour rotation. And the stars and the constellations that stay above the horizon are known as circumpolar. And by the Polaris is a circumpolar star in the sense that it doesn't dip below the horizon throughout the evening, or through the evening and also throughout the season. Because as some of you may know, that some constellations are seasonal. So, for example, Orion the Hunter is a winter constellation. You will see it at the beginning of the evening in the winter months, and if you're up very, very late, like 4 or 5 in the morning in August, you'll see it right before sunrise as well. But it's predominantly a winter constellation, and in that sense, the stars of that asterism or constellations actually are not circumpolar. But Polaris has always held a special place in my heart because when we go camping, we would often use it to assist in our navigation. We wouldn't actually use it as our sole means of navigation, but it was nice to know that we had that in our little toolkit. And one of my life goals is actually to learn how to do celestial navigation on the sea. So when you're sailing, to use the stars to help find your bearings on a clear night. And I think for that you'll definitely need Polaris and a few other anchor points in the sky. Yeah. I think Rohit here has lined up. He's moved the telescope to Polaris, and you can see at the very bottom there are 3 video feeds. Those are webcams of the observatory. The one on the far left is the interior. The one in the middle is looking towards the west, and the one on the right hand side is looking towards the east. And we see that we've rotated, and I think Rohit's trying to capture a real image, not real. That's not what I mean. Or I mean, it is real, but a real time image.
Yes, thanks, Sarah. We have it at the center of the page right now.
Oh yes.
Yes. Now, allow me to, let's see if I can zoom this a bit and make it a bit more. Oh, is that any better, Sarah? Are you able to see that?
I believe the zoom is at the top toolbar.
Yes.
It's currently at 25%. I believe you could drop down the menu and zoom in a little bit further, but whatever you just did is also working.
Oh, okay. What I ended up was doing, I just ended up zooming into the entire screen, but I'll keep that in mind for next time. Thank you.
Yeah, absolutely. I think for those of you who are watching our stream, on the right-hand side, you can see actually some of the settings that we employed for this particular image, and you can faintly see Polaris in the center. Rohit, I think we might need to increase the exposure just a little bit. I think it's stacking, is it not?
No, so for objects with star, for example, with stars, we're just doing normal capture, but I can definitely increase the exposure.
Yeah, I think that might be a good idea.
Sure, we can try that. And let me go ahead and also zoom in a bit more.
Before this call, Rohit and I were chatting about how much easier it is to run a Starry Nights in person, because the tools are right there in front of you, the equipment is right there in front of you, and you can diagnose or troubleshoot issues right in front of you. But when it comes to online streaming, there's a whole extra factor of internet quality coming in, and you have to diagnose everything from a distance. So it's a miracle that we were able to transition so quickly and smoothly last year from in-person to online. And I think you're on the right track there, Rohit. I can see definitely Polaris right there in the center. It looks like a small little diamond, a single diamond in the sky. But actually, it's a triple star system. So that one bright dot actually represents 3 stars that are rotating or orbiting around each other, which is quite miraculous. I don't think you can actually discern between the stars here. It's a bit too turbulent to see, but they rotate around themselves they orbit around themselves in a rather complex pattern, one that is difficult to describe in words, but it is beautiful, and it is our anchor in the sky. It's always there, so long as the clouds don't block it. And you can actually see it's kind of jiggling around a little bit. That's from the atmospheric turbulence. So we've had some pretty warm days, and our atmosphere is bubbling and quite warm, and the light that comes in from the stars at that far distance, they travel through the dead cold space, and then when they enter our very warm atmosphere, the light gets distorted, it gets disturbed, as it's traveling through a really, really warm environment compared to the outer space. It's kind of like when you open your hot oven and you kind of see the air above the hot oven kind of shakes or disturbs. It doesn't look quite right. That's the same principle here. The light is being distorted by the warm atmosphere. So the colder the evening, the clearer the night.
Yeah, that's a great point that you mentioned there, Sarah, especially when we're doing deep sky observing out in areas where there is a dark sky. We have to be in areas where obviously there's less impact due to light pollution as well, which does affect your viewing. And you know what? It actually affects the viewing of when we're looking at stars as well. I know in my past experiences when I've been at dark campsites or dark skies, in dark skies areas, that's always been the case where certain times an object, let's say, I'll take Merit for example because that's where I would usually go. The viewing there would be 10 times better than I'm viewing, let's say, from Portico, which is in close to Vancouver. So yeah, great point that you've mentioned there.
Yeah, exactly. I've frequently heard, I've frequently heard astronomers complain about the atmosphere, saying, "Oh, this darn atmosphere! It's really messing up my observation." And while I tend to agree that the atmosphere can be a bit tricky and problematic to view through, I do like breathing.
Yes.
I do like air, and I think the amount of time I could enjoy a totally atmosphereless or a totally clear evening and a clear starlight without any atmosphere would not outweigh my desire to breathe.
Yeah, that's a great point there. Was there anything else that you wanted to share about Sarah with Polaris?
I think for Polaris, I think that's touched. I think we've gone through that. I think, if I'm not mistaken, you wanted to chat a little bit about the summer triangle.
Yes, I did. Thank you. So one of my favorite things to look at it, and this is going back to how you can start into amateur astronomy, is you just have to look up. That's the first thing you should do. Just look up and see, try to figure out what the constellations are, try to figure out which stars there are, and my favorite thing to look at in the summertime is the summer triangle. Now, the summer triangle is actually formed between with three stars. It's Altair, Deneb, and Vega. Now, Altair is actually part of the constellation Aquila, and it's about 16 light years away from us. Um, Now, what we'll do is we'll take a look at Altair, and now because we are using a telescope, we can't actually, show the triangle it forms. However, I do encourage everyone, whether it's tonight or tomorrow night, to go outside around 10:30 and just look directly up. Find three bright stars, relatively bright stars, um, and they should be directly overhead from you. And you'll notice that they form a pattern. And that pattern is what we refer to as the summer triangle. It's a prominent target to look at in the summer skies, and there's actually quite a bit of deeper, deep sky objects in those constellations as well. So I'm just moving the telescope over to Altair right now. Um, but and then I'll move over to Deneb and Vega as well. One thing I just wanted to share about Altair is the poles of the star. Um, they're actually flattened as opposed to our sun. Now, the reason behind that is Altair has this really high rotation speed. I think it's about 300 kilometers per second. And because of that immense speed, the poles have actually flattened itself. Now there are quite nice images, representations that the Hubble Space Telescope was able to take of this, and it's quite interesting to look at um, uh, the way the poles are flattened as opposed to our sun itself. I've just changed the exposure a bit here, just because Altair is relatively bright as opposed to Polaris, so we don't actually need a long exposure for that. And I think we should be able to see it. Yes, and if I'm going over, yeah, I think I'm looking at the screen here, and it looks like, yeah, so that in the center itself, this is what we're looking at. We're looking at Altair right now. So this is actually the first point, or the first star in the summer triangle.
Now, Rohit, is there not a complementary winter geometric asterism? I'm forgetting the name, but there's a summer triangle and there's a winter what?
Yes, I believe there is. I think. Let me think if I remember this correctly. I'm just gonna have to see if you're able to Google that, Sarah, and just let us know.
Don't worry. I'm gonna start
Okay.
googling right now because we both look a little bit.
I know.
The winter
I know.
triangle and the summer triangle. Oh,
I
the winter
know.
hexagon.
No, I think Beetlejuice is one of them, if I remember correctly. I think it's Beetlejuice and maybe Sirius. I can't remember.
Well, when in doubt, Google it.
Yes. um,
So it says apparently here, the Winter Triangle stars Sirius and Procyon,
okay.
Beetlejuice, and Aldebaran. Aldebaran.
Aldebaran.
I
Okay.
read these names. I don't ever really say them. So
Uh, yeah, you know what? I think this is the one thing I really enjoy about our virtual Starry Nights is we find new things which we vaguely remember at some point in our time doing this, and all of a sudden we'll remember. Oh, right, there was something like this. Let us look it up real
mm,
quickly, and at least we're able to share it straight away, which I really enjoy.
yeah, exactly, exactly. Well, I think yeah. So if you have the chance to observe the winter, or sorry, the summer triangle outside, do try that out because they are bright stars. So you can usually see them, no matter like you can usually see them even with this light sky in the summertime.
Yeah, absolutely. So I hope everyone is able to see the SkyX software that I'm using right now. And um, right now we're pointing at Deneb, and Deneb is actually in the constellation Cygnus, or Cygnus the Swan. And this star is actually 2,600 light years away from us. Um, and you know what? This is the one thing I just absolutely admire about astronomy, that you can have a star which is 16 light years away, and you can have a star which is 2,600 light years away, but to our eye they look like they're just right next to each other. um, and this is something I'll never be able to it always makes you take a step back and realize how small we are in this universe itself. um, So yeah, so we're looking at Deneb right now, and then after this, I will be moving on to Vega, which forms the third star of the Summer Triangle.
And actually, in the chat, I'll pop in a link to a graphic just to show you the where the summer triangle is in the sky, just so people have an idea of what we're talking about. A lot of people, we frequently get the question of, can we see whole constellations, or can we observe a meteor shower through the telescope? And those are excellent questions, and the answer is usually, I mean, you could, but it wouldn't really make, it wouldn't be really that lovely to see because constellations are quite large objects in the sky. They're quite large asterisms, um, and for meteor showers, the beautiful thing about a meteor shower is laying on the ground and watching the shooting stars pass over your head. And when you have a large field of view, you have a larger chance or a bigger chance of observing something passing across the sky. But when you're looking through a telescope, you have a very, very tiny field of view, about the size, about the area of your of a straw, actually, when you're looking through a straw. And so the chance of seeing something pass through that surface, that area that you're looking through, is a lot less likely, or a lot smaller, sorry. So that's usually why when it comes to big, beautiful celestial events or objects like asterisms or meteor showers, or, sometimes lunar eclipses are cool to see through a telescope, but like definitely a solar eclipse, watching everything go dark and then brighten up again can be such a incredible experience when you look at it without a telescope.
that's a great point that you mentioned, Sarah, just about how many things we can see with our naked eye. I know for the eclipse that happened in 2017, the solar eclipse. I know Vancouver, it was partial, um, but there was quite a lot of folks that from Vancouver they traveled to Seattle,
Mm,
and sorry, Portland, I believe, and they were able to see the full eclipse. So there's another one happening in 2024, and that's going to pass by eastern. That's going to pass through, I believe, eastern United States. So there'll be a solar eclipse on that side as well. So something to look forward in 3 years' time. And yeah, again, it's going to be a different event as opposed to the eclipse in 2017 because I and you know what, this is a bit embarrassing, but I'm going to share it. I was in Kansas City because that was meant to be
Oh,
the high point of the eclipse in terms of the totality duration,
mhm.
and it was clouded over.
Oh
It was
no!
yeah, it was just clouded over. I did experience darkness for I think it was like 2 minutes and 27 seconds or whatever it was.
Mhm.
Um, but didn't see the corona at all, didn't see the diamond ring.
Oh
Uh,
no!
did see first contact, which was great. But yes, I'm hoping and fingers crossed for 2024, and I don't know how that
Well,
event is going to be like.
I'm definitely crossing your fingers for you, and let me tell you, I'm glad you got to see the solar eclipse in 2017 because I'm also pretty embarrassed to say this, but I completely missed the solar eclipse in 2017, and for the most, ironic reason. I went to Copenhagen to take a master's research course in astronomy, and we went down to the Canary Islands to use one of the many fantastic observatories down there, the Nordic Optical Telescope. And it was during this period of being in one of the world's best observing sites that the solar eclipse happened, and I completely missed it. Completely missed it. And I felt a little bit silly because I had put so much effort into planning this course and planning this trip and making sure that I qualified for it and getting in contact with the prof a year in advance and him letting me have a spot in this really competitive program. And then I show up and it just so happens to line up with the solar eclipse and I'm on the wrong side of the earth.
Oh wow, that is something.
Yeah,
And
that was a Sarah moment, that's for sure. So I am really, really going to make an effort to make sure I see the 2024. Nothing but clouds can stop me.
and you know what the worst part was? On my way back, there was a thunderstorm in Kansas City, so I was stuck at the airport
Oh,
for one night because the flights were canceled.
oh
Um,
no!
yeah, so I think
Mother
that was
Nature was rubbing it in.
yeah, I think that was the biggest sign that I got. I should have never been there at all. So um,
Well, let's
okay,
take a look at what you've got set up for us.
yes. So as I mentioned, we're looking at Vega right now, which is in the constellation Lyra. Now, Vega is actually a very it's a bluish star itself, and it was actually a North Star about 12,000 years ago. And it will be again in about 14,000 years. So I won't be here for that event, but whoever the future civilization is, or even if there is one, I'm sure they'll be able to they'll be able to figure out that Vega is now the North Star itself. Now, Vega actually is very close to me because one of the earliest memories I have of watching an astronomy related movie was the movie Contact, and it's based on a book by Dr. Carl Sagan. And the Vega is actually the high point in the movie because this is the star where we sent sorry, where aliens contacted us from. Um, and it's a really lovely movie itself. Just the direction, the acting itself. And then again, I point out to what I said earlier. It just shows how small we are in the universe itself. Now, the star itself is about 25 light years away. And a really cool thing about this star is it'll actually um, become the brightest star in the sky in roughly 200,000 years. And it will be the brightest star for roughly 270,000 years. So, really nice things happening in the future of Vega, and and in the movie itself, there is a civilization in around Vega itself. So, They're definitely going to be going through a lot of changes in the star itself, which I'm sure will, if there is a civilization there, would be something interesting for them to look at. One last thing I wanted to share about this is this star itself was actually the first star to have its distance measured through parallax, and the first star to have itself photographed with a spectrum itself. So as I mentioned again, as I mentioned before, sorry, great things happening for Vega in the future, and of course, great things have happened for for the star itself in the past as well.
Well, it's yeah, it's quite a spectacular star, and I think actually it's dark enough now that we can start maybe moving towards more fainter objects. We started off with stars because we know that they can be quite reliable in terms of seeing them, despite the sky being quite bright. But I think maybe we should move into some star clusters. What do you think?
Yeah, you know what? I think that's a great idea. The one thing about the summer, and as Sarah mentioned, was the fact that we have to wait for it to get properly dark, which never ends up happening. But anyways, let's jump in. Did you have a star cluster in mind, Sarah, that you wanted to
Yeah,
start with?
yeah. Let's do M13.
Oh, great. Okay.
M13 is quite a spectacular one, and it's quite popular actually. And it's one of the objects that we've imaged at the observatory. And I'll pop a link in the chat below here. I'll just pull it up right now. M13. Dr. Howard Trottier imaged this object, and it's really quite spectacular. He put a lot of work into processing it and showing its beautiful colors. So in the chat here, you'll see a link to the Trottier Observatory images. And then if you scroll down, you'll see Great Globular Cluster in Hercules and Messier 13. That's what we're going to be pointing towards. So there's a reason why it's called the Great Globular Cluster in Hercules. It's quite a large, impressive globular cluster. And it's, I think, something that is interesting for a lot of new astronomers is the fact that that globular is an important description, or gives you an important clue about the object that you're looking at. There are different kinds of clusters. Ooh, and actually Rohit here is pulling up a live image of the cluster. Oh my gosh, that's spectacular. That's beautiful.
And sorry about that, Sarah. I know you were going into the conversation, and I was a bit fast there, but while you're discussing this object, I'm going to do my best to clear up the image here.
Oh yeah.
One thing I just wanted to let everyone know, we're gonna just because of the way because we are in the summer itself, and just because of a lot pollution as well, we'll do our best to have a really nice image, as nice it can be. But go ahead, Sarah. Sorry about that.
Oh, no worries. Thanks for that little additional info. So as you can see, so the image that's on the screen live stream is a live image. It's what light is currently hitting the telescope right now, and you'll notice that live images compared to processed or refined images on the internet are very, very different. And that's because there's a lot of work that goes into astrophotography. Sometimes there's a bit of a misconception that you just attach your camera to a telescope and you take a snapshot. And the reality is that there are many, many more layers that go on beyond just that. So one of those layers is that you need to expose your camera for a longer period of time to get those that faint light into your onto your sensor. But you don't want to overexpose it such that the core becomes overblown. You might have just briefly seen on the live stream that the core of the cluster was just really briefly overblown, and that can be a tricky balance. And one way to actually mitigate that is, instead of taking one image of 2 minutes exposure, for example, and risking the core being overblown, is that you can take multiple images at much shorter exposure and stack them on top of one another. Now, just to kind of give you a visualization of what this might look like. Imagine that you have, let's say, an overhead projector sheet. So some of us might remember that the teacher would roll in an overhead projector and place a transparent sheet on the projector and allow the light to pass through from the bottom through the projector, the image that was on the projector, and then to be reflected onto the wall. If you were to add on multiple layers of that same image, you'll have darker and more refined details in the final product when you look at it on the wall. If each layer is only a light shade of gray without much detail, but you add 3 or 4 or 5 of those same pictures on top of one another, you'll get more clear edges and contrast in the overall image. That's a little bit of a difficult way to explain it, but I hope you understand what I'm trying to get at, in the sense that when you stack images, you can control which parts you want to have less bright, such as the core, and which parts you'd like to increase the exposure, the brightness, such as the outer edges, the dim parts of the object. Because if you take a picture with 2 minutes exposure, just one picture, yes, the edges will be exposed just fine and you will see the detail, but you will have overwhelmed and overblown the sensors or the pixels on your sensor where the center of the object is, such that you've lost the data. You cannot retrieve that. It is white. You can't find any details or decrease the exposure. So that's why stacking images is really useful, because you can actually prevent overblowing the core of an object. Now that was a huge deep dive into astrophotography, but the key point here is that astrophotography has a lot of layers to it, quite literally, but also in terms of the workflow. And you can see here Rohit is playing a little bit with exposure and color gradient, and color gets a little bit tricky because we don't actually know we do know what things are meant to look like, but it can be really difficult to get the color just right, and a lot of times astrophotography can have sometimes a little bit different color, because you might have, okay, let me back up here. Color is defined by the wavelength of light. So longer wavelengths of light tend to move into the reds, and shorter wavelengths of light tend to move into the blues and the indigos. However, there is no objective cutoff between red and orange, or orange and yellow. So different filters will have different gradients of where red starts and where orange begins. And the same thing with computer software processes. Some will define red to be a little bit different than orange, and some people will change the color just to appease what they think the object looks like a little bit more. So color can sometimes be a little bit tricky to have consistent over objects, but generally there's a consensus of what it's meant to look like overall. If you observe if you saw this star cluster and it was totally green, you might ask some questions. But this is a really great representation. And you'll notice that there are some blue stars and there are some red stars. And the red stars, by the way, this is a fantastic image, Rohit. I'm thoroughly impressed. The red stars are older, and they are less hot. They're cooler than the blue stars. The blue stars tend to burn quite hot, quite bright, and they're younger than the red stars. And you can tell when a cluster is old, when it has a large number of red stars. Now, Rohit, I think this image might be tinted a little bit too red, maybe just a little bit, but if you were to make it just a little bit more blue, you'll notice that there are some blue stars, but there are quite a few red stars. And you can actually identify a cluster's age, or general age, by the number of red stars that are in there. So globular clusters tend to be quite dense, as you can see, because they've had time for stars to gravitate towards the center point of gravity of the object. And they've had time to age, so they become red. So that's how you can tell that this star cluster is an older cluster and therefore a globular cluster. So that was a deep dive into globular clusters. This one, M13, is about 145 light years in diameter. So that object you're looking at right now, this one screenshot, or this one image, is 145 light years in diameter, which is quite spectacular. And we have here in the chat mentioned that open clusters are younger than globular ones. That is correct. So open clusters tend to be, they're more spread out and have more blue stars, and they tend to be younger. Back to M13, this one is about 11.7 billion years old, which is quite impressive, and it's 24,000 light years away from Earth. So remember, our sun is just 8 light minutes away from Earth, and the nearest star other than our sun is about 4 light years away. That's Alpha Centauri. So for this to be 24,000 light years away is a little bit of a jump.
That's absolutely great facts that you've mentioned there regarding this object, Sarah. And yes, it's all about this fine tuning when we are in this virtual environment. I mean, the one thing I wanted to mention is when we look through a telescope and we look at M13, it does not look like this. I mean, there are some aspects which are similar to this, but just again, which is what Sarah mentioned, is that we're doing stacking of frames right now, and she gave a really nice piece about astrophotography as well. But when we are using binoculars or telescopes, the core of this object itself is what comes out the first time you look at, and you just get blown by the fact that there's so many stars at the center of this of this object, and if I remember correctly, I think it's the roughly the cluster itself is approximately 60,000 solar masses, if I remember correctly. Is that right, Sarah?
Yep, that's right. Which is massive. And correct me if I'm wrong here, but the mass, or I guess the incorrect term would be weight, but mass in terms of like the matter that is there. If you take our sun and multiply the mass of it by 60,000, you would have this cluster. So that kind of gives you a general idea of how massive this object is compared to our puny little sun.
Yeah, absolutely. And you know what? This is one of my favorite things to look at in the summer sky, and even sometimes in fall and closer to the winter. In fall, I would say not so much in the winter, but definitely in the summer and the winter, in the fall. Sorry, just because it's easy to spot. You don't have to do a lot of head tilting when you're looking through the telescope itself. So that's a great plus point. Was there anything else you wanted to share about this object, Sarah, or do you think we should move on to something else?
I think that we have covered this one thoroughly. I love this object. It's just so beautiful to look at. You did quite an excellent job in capturing it live. And I just want to make one note for our audience. You're very lucky in the sense that, or we are all very lucky in the sense that remote Starry Nights allows us to show live pictures of right now, and they tend to be a bit better quality than what you would see through the telescope, because our eyes are not capable of giving us long exposure. We're not capable of stacking images in our eye, but Rohit here with his great skills can provide us a beautiful image of a few stacked frames to show us what it looks like in real time. So thank you.
Thank you so much, Sarah. I'm lucky. I'm lucky. Actually, everything is working okay today. I would say that.
Yeah.
I know earlier today we were a bit panicky, but we won't go into that.
We're doing really well. We got on an hour early and made sure things were set up. I feel like we should test our luck a bit. I feel like we should, step into a galaxy.
Yes.
I have a good feeling.
Yes, I agree. I think we should venture out a bit, and let's see where we can go with. Did you have something in mind? I know I have a galaxy in mind, but let's see if maybe we're thinking of the same object.
Well, are you thinking of the pinwheel?
Yes, I was.
There we go.
I figured we should start with Pinwheel and see how things
Oh,
turn out with that object itself.
absolutely, absolutely. And while Rohit is moving over to the Pinwheel Galaxy, I'll just quickly mention again that the link I posted in the chat that leads you to our the Trottier Observatory's images and observing reports. You can see the pictures that we've taken through this telescope that you're viewing through. And one of those images is actually Dr. Howard Trottier's image of the Pinwheel Galaxy. So do take a look at that. You'll see what hundreds of hours of work will result in. It's quite a phenomenal object, and I'm absolutely mesmerized by his work.
I would like to second that. I mean, I've seen the results he puts out, and I just want to mention he was recently featured in Astronomy Picture of the Day. One of his
Oh
objects
yes,
got into that, and I know in our conversations that he's mentioned he has been. Um, it's been a long it was a long process for him to get everything on there, but on published onto the website as well. But it was great that his work was recognized by his peers for sure. Um,
absolutely. And for
okay,
those of you who don't know, I'll just take a quick moment to say here, if you don't know what astronomy photo of the day is, or also known as APOD, I'm going to paste the link into the chat, and I urge you with the greatest sense of I guess urgency, to check this out, because every day a new image gets posted up on APOD. And it's just some remarkable work by astronomers, amateur and professional, all across the world. So please do take a moment to look at astronomy picture of the day. All right, back to you, Rohit.
okay, and while I am trying to uh, play a bit with the filters here. Um, Yeah, so what happens is when we are looking at star clusters and we're looking at galaxies, we tend to use a different binning, and I'm not even going to attempt to explain this because I know I'm going to fail horribly. So if Sarah would like to take the lead on explaining the binning, I would really appreciate that.
Absolutely. So when we do astrophotography, we have a few tricks up our sleeve. And one of those tricks is something called binning. Many of you may be aware that when we have a camera sensor, we have many pixels. Those are the units which capture the light, the sensitive part of the camera sensor, which picks up on photons and translates that photon into what we visually see, which is a pixel. And depending on the wavelength of light of that photon, the pixel will take on a different color, red, green, or blue, or maybe an intensity of whiter, and display that on the screen. Now, sometimes what we'll do is we will actually group these pixels together into groups of 4 or larger to call something through a process called binning to make megapixels or groups of pixels. And this can be done for a number of reasons. I haven't totally been sold on why we do this all the time, but what I do know is that sometimes you actually, how do I remember this? Sometimes you want to group pixels together in order to. Actually, you know what? I'm blanking out here for a moment. I know that, for example, when we do astrophotography, we take pictures with the least amount of binning, so the most granular level of pixels for the clear filter. So when we want to get details of the structure of the object, but when we're capturing the other layers, the color layers of the image, we will group the pixels together to capture the color, because we don't need the details of the color. We just need the color broadly, and that helps reduce, I guess, the size of the image. Some people prefer to not bin at all, and some people prefer to bin. I'm not completely sure as to why some of the benefits of binning, and I'm sure somebody could explain that better than I can. But what I will say is that I forgot to mention that sometimes some astrophotography cameras are actually monochromatic or black and white. So they don't, the sensors of the camera, the pixels of the camera, are not actually sensitive to, they don't register the wavelength of light, they just register the intensity of the light. And the reason for that is that you can actually improve the resolution of your camera by telling all your pixels to register the intensity of the light rather than to be red, green, or blue. You can improve the resolution by making everything just sensitive to the intensity of light. And in order to get a color image, what you'll do is that you will place a filter in front of the sensor, either red, green, or blue, and only allow one particular color of light to pass through. That way, if you have the red filter in front of the camera, when you take that picture, you know that all the brightly lit pixels, or all the pixels that have received light or collected light or were activated by the incoming photons, that is red wavelength light. And you repeat the same process with the red, the green, and the blue. And when you stack these three images on top of one another, the pixels that all are intensely and evenly lit in red, green, and blue will come across as white, because when you mix light of red, green, and blue, you get white. But then let's say one layer, one of these images in one particular area has more intense blue, like the pixels were more intensely activated in the blue frame than it was in the green or the red. That particular area will come across more as blue. So that's how you get the different colors in an image using a monochromatic or a black and white camera, and that way you can increase your resolution by not having to assign your pixels to either red, green, or blue, but telling them, look, you're sensitive only to the intensity of light. So that's I don't know much about binning, but I do know why we do stuff in black and white.
And you know what? I think you definitely did a much better explanation than I would have for sure. So thank you so much for mentioning that. So we're just in the process of seeing how this turns out. I may have to switch the profile a bit, but let's see. And hopefully we'll be able to look at M101. Yeah, I think we may have to try a different profile. What do you think, Sarah? Should we try with the bin 2 instead?
I think you're right. I think the Pinwheel Galaxy is evading us tonight. M101 is not the stars. Maybe should we try the Sunflower?
Yeah, absolutely. I think we can. I'm just going to load this up profile and quickly change it, and perhaps we're able to see something. And if not, then we may just switch to. We may just go ahead and switch to the Sun Galaxy instead. I think that's a good idea.
Sounds great.
And once again, thank you everyone for being patient. I'm just in the process of setting everything up. So well, let's see if we get something this time.
In the meanwhile, usually on our starry nights, we tend to look at the moon. Because the moon provides a beautiful landscape to gaze upon and admire. But the moon doesn't come up until quite late tonight, which is both a good thing and also not a great thing. I personally love looking at the moon, but if the moon is too bright, it can wash out the sky and prevent you from seeing fainter objects in the background. So tonight will not be a moon night. It will be hopefully a galaxy night. That's our greatest aim tonight.
Yeah, I definitely agree with that, Sarah. I think sometimes that does end up happening, and sometimes it just is not fun to look at when the moon is quite bright. You know what? I think we may have to change the settings a bit again, but let's. I think we can move on to the sunflower galaxy and see how that comes out. What do you think, Sarah?
I think that's a great idea. And as you transition to the next object, I mean, the good thing is that we created a detailed itinerary of many objects just for this scenario where something doesn't quite work out. I think it's worthwhile to mention that while SFU is a fantastic place, specifically where the observatory is located, which is near the quadrangle. While it's a great location to get people engaged and to draw in passerbys into the observatory, it can be pretty dismal for sky quality. You know, we're above the city, which is great. However, we do have light pollution from Vancouver from I guess all the way from the southeast to the southwest, and I guess even out westwards. That light pollution definitely invades our seeing ability. One other small annoying thing is that some of the lamps and the I guess they're lamp posts, they shed too much light into our frame of our fields of view, and we've tried to negotiate getting some lamp covers on some of the lamp posts, but I don't know. People complain something about safety. I sarcastically say that, of course, it's really important to make sure we have the appropriate lighting. It just gets a little bit tricky when that lighting is very high above the ground and obstructs a bit of your view. You should come up with a more like mid-level lighting, so above the human height, but below the dome of the observatory.
Yeah, absolutely. And the one thing I just wanted to point out at this stage here, because I know we are talking about light pollution. Uh, uh, I believe Lee from RASC Vancouver, he is the light pollution abatement coordinator itself. And you know what? Ever since I've been a part of RASC as well, I know they've actively, raised this issue a lot of the times. So it's definitely something that's had a presence regarding the way we look at certain things now. Um, so I have moved to the Sunflower Galaxy, and let's see how it comes out now. Um, Let me see if I load it properly. I think I did. Okay, yeah. So we'll just give it about 20 seconds. So it starts collecting the exposures, and then hopefully we're able to see um, some galaxies. And if not, then I apologize. We may have to move on to nebulas. I think, Sarah, is that correct?
Yeah, I think so. 20 seconds, 20 more seconds with you. Oh man, I can't bear it. Um, no, it's this is unfortunately something we were a little bit afraid of, was was not being able to see some objects because of light pollution and a bright sky. But if all else fails, we could definitely try a couple more galaxies that we have up our sleeve, or maybe if things really go south, we could try and look at a couple more star clusters. We've got that as well. But yeah, it's you mentioned light pollution, and it's a big problem, and I think it's a problem that's not really talked about as as a society expand and inhabit more land and bring a lot of light to where we live and walk and work. It gets harder and harder to see the night sky, and add on to that as well pollution of the air quality kind. It gets really hard to see the night sky and to see the Milky Way. And some people have actually never seen the Milky Way from with their own eyes, which partly due to the fact that it's very, very, very difficult to see the Milky Way from the city. But I really hope we move in a direction where we have, of course, conservation of forests, old growth forests, and rivers, and streams, and mountains, and glaciers, but also of night sky patches where we don't have very bright lamps pointing needlessly upwards, or too many planes flying over in a specific direction. I hope we move towards a direction where we have sacred spaces for observing.
Yeah, and just on that note, sir, I don't think we're gonna get any lucky with the galaxies.
No,
We got something in this image block, but I don't think this is the Sunflower Galaxy as far as I remember.
no. Should we try the Whirlpool Galaxy?
Yes,
Give that one
perhaps.
a shot. And if that
Yeah,
one really doesn't work out, if we've really exhausted all our options, maybe we could try. Maybe we could try some globular clusters.
yes, perhaps we can do that. Yeah.
Yes, Jennifer also points out, or too many satellites. And I was about to say as well, it'd be nice to have a space where we don't have satellites crossing over. But unfortunately, I think with satellites, it's a bit more. First off, there's just so many of them. I once saw a map of where all the satellites, active satellites, are. And it was just like this cloudy haze of thousands of dots, probably even more, tens of thousands of satellites scattered across Earth's sky. I think it'd be really difficult to carve out a piece of sky where satellites were not allowed to pass through. I think it would cause quite a commotion in the international community.
I know, and recently with the launch of Starlink satellites with SpaceX, there was a lot of talk about astrophotographers and even professional ones. They've started, trying to write up software which are eliminating the pattern that the Starlink satellites will cause in the night sky. I know, like the first time it happened, um, the first time it happened, someone came out. Someone was very puzzled, as in, what are they looking at in the night sky? Like, why is it just a dot of 14 bright lights moving in a relatively vertical line across the zodiac? And it's only after someone pointed out that, yeah, it's perhaps it is perhaps the Starlink satellites itself.
Oh, interesting.
Okay, so
Uh,
we'll try to do a 40-second exposure, and let's see what we get with the whirlpool. And yeah, fingers crossed, we take a look at that one. I know, if I remember correctly, Sarah, I think Howard has done one for. Oh, I think you have done one for the whirlpool, if I remember correctly.
yeah, it was a team effort.
Yes,
Where
you
Matt and I
did.
took the pictures, and Howard worked his magic in processing.
Okay.
Yeah, I could. If this image doesn't turn out in terms of live, you can show on the screen one of the images that our image version of it, our processed image version of it. And actually, fun fact: the Whirlpool Galaxy was the first light on the telescope, this specific Trottier Observatory telescope. So when we opened up the dome and we tested out this brand new equipment back in 2015, we're so excited to start taking pictures. The first thing that we looked towards and took an image of was the Whirlpool Galaxy. So it's quite full circle.
Yeah, you know what? Just bear with me a moment, and I definitely want to share that. So let's see if I can quickly pull this up.
Oh,
Uh,
actually, I think there might be a little bit of something.
yeah, there's definitely a little bit of something, but it's not. Unfortunately, again, light pollutions and just the conditions today. And just let me see if I can paste this here.
I think despite the conditions, you're doing a really great job. Sometimes I find these warm summer evenings can be a little bit deceiving. People will look towards the sky and say, "Oh, it's so clear out; it must be perfect for observing." And then when you actually pull out your telescope, it's just hazy as heck.
I know, and you know what? Anyone who ever asked me is like, oh, it's the summer must be amazing for you. You must be going out every night. I'm like, no, no. Summer is the worst time to have been stargazing. We love going in the fall. We love being out in
Oh
the
yeah.
cold with four different layers and hot
Oh, the
chocolate
colder
and
it is, the
coffee.
better.
Yes. So Sarah, I have your image up, but yeah, if you want to talk a bit about that, because I know you and Matt collaborated on this.
Yes, so this is the Whirlpool Galaxy. It's actually a combination of two galaxies that are interacting. You can probably tell right away. Um, and this is taken directly from the observatory. This is the Trottier Observatory, and this is, I believe, about 100 pictures combined together. And it's Dr. Howard Trottier processed this image, which was quite amazing work. You can see the beautiful nebulosity at the arms of the galaxy. So you can see here that the smaller one, which is known as 51 Messier 51b, and the larger one in the center, also known as Messier 51a, are interacting. So the smaller one is actually being drawn slowly into the larger one by its gravitational pull. And if you give it a few million, maybe billion years, probably millions of years, they will eventually become one unit, one galaxy. It's quite beautiful. I sometimes refer to it as galactic cannibalism. Gives it a bit more of a human aspect to it. Well, actually, no, that's a terrible analogy. But yeah, it's quite a fantastic. It's such a beautiful image, and it's such a beautiful object to look at. And I think one thing that I'm very proud about this object is that this image was featured on the cover of the Royal Institution's Summer 2018 guide. So the Royal Institution is a very prominent science institute in London, England, and they have a really incredible museum there. And I entered this image on behalf of the team, and they accepted it to have it as their cover image for their brochure for summer 2018. So I take pride in that. But yeah, so a few more things about this beautiful galaxy that you might want to know. It is quite far away if you're planning on visiting. It's about 23 million light years, which means that the light you are seeing from this image, it took 23 million years for that photon to escape from this galaxy and make its pilgrimage towards Earth and towards our telescope. It's about 400 million years old, and the diameter of this beautiful galaxy, and by diameter I mean the diameter of the blue disk, is 60,000 light years. And that seems really big, and it is. But keep in mind that the Milky Way, our Milky Way, has a diameter of about 105,000 light years. So this is just a little bit over 50, or half the size, about 60% of the width or diameter of the Milky Way. So if this looks big, our galaxy is even bigger. So, and merging galaxies is, as Zena has pointed out in the chat, is not uncommon. It's quite interesting. And actually, our galaxy, the Milky Way, will, over, not in the near future, in very much the distant future, will actually combine, or collide is not the best word, because actually there won't be a whole lot of colliding of objects, but they will merge. Andromeda and the Milky Way will eventually merge. And Andromeda is only 2.2 million light years, I believe, away, and this one is about 10 times that distance, 23 million light years away. So that's this beautiful object. I'm very fond of this object. It's has a very special place in my heart.
Thanks so much for sharing that, Sarah. And you know what? The first time I actually viewed this object itself was, and I can't believe I'm saying this. It was actually from Porto Cove, and
Oh yeah.
yeah, and it was a cold night. I remember that, maybe it was November, I want to say, and I was out there with some of the individuals from Rask as well, and that was the first time. And the second time I saw it was from Merit as well. And you know what? Both the times that I've seen it, it's remarkable, and obviously the details that the image is able to bring out, it is not something that perhaps you'll see from your own telescope, but you know what, the when you look through the telescope and you realize what's happening at that galactic scale, it just, again, I go back to what I've said this probably a couple of times, that we're very small in the universe.
Oh,
but
we are.
but yeah.
We are. infinitesimally small, but
Yes.
we have a very big impact on our Earth, quite disproportionately large impact.
um, so yeah, I think Sarah, should we try for a nebula instead? Perhaps we'll be luckier there.
Yeah, we're approaching the end of the evening with about 10 minutes to go. I think we should try our luck
Should we try the
at a
dumbbell?
nebula. Do we have a particularly bright one here? I'm trying to think. I feel like we might want to try the dumbbell nebula.
Okay. Yeah, I was contemplating between the ring and the dumbbell, and I think maybe we can try the dumbbell and see how things go there.
Yeah, I
And
think the dumbbell fills up a little bit more of the field of view, so if it does appear, it'll be a little bit more fulfilling to see. And actually, interesting fact for our viewers, the Trottier Observatory team has actually imaged the dumbbell nebula before, and it was actually with Rohit, Zena, myself, and another team member of ours named Ryan, who's not here tonight. But it's quite impressive. I think it's a fantastic object, but the name dumbbell, it makes me really wonder how did astronomers can be quite creative. They say scientists are not very creative when it comes to naming things. They name laws after themselves, or by numeric order. But when it comes to astronomers, they look at the sky and they say, yes, that's a hamburger. We will call it the hamburger galaxy. Or yes, that is obviously sombrero. We're gonna name that the sombrero galaxy. So it's always interesting to see what people name objects.
yeah, and the one thing I wanted to share was this was actually the first planetary nebula found by Charles Messier. So and I'm sure uh, this was probably discussed in earlier Starry Nights as well. But Charles Messier in 1764 he came up with these objects where um, his goal was to find comets in the night sky, and he made it a purpose to try to find as many comets as he could. And he started off by finding all of these objects, and it was an indication to other astronomers that, hey, don't look in that direction. That object is not a comet. And he made a chart of roughly 110 objects, I believe, and 30, I think it's about 30 to 40 of those are in the southern hemisphere, but the rest are in the northern hemisphere. And one of the objects is the dumbbell nebula, and I'm afraid I may have to change a bit of the settings, and maybe that's what's the problem is. Maybe I'll maybe I'll
Absolutely.
maybe I'll just switch back to our bin two, and we'll try to see if we can get that image out there. Uh,
I think that's a great idea. And while you're focusing on that, I can mention to our audience that I had a thought in my mind and now it's gone. My apologies. It was at the tip of my tongue and now it's completely gone. But in the meantime, as I collect my thoughts again, Lee in the comments mentioned that the dumbbell nebula actually does look like a dumbbell, and that I do agree with. It definitely looks like a dumbbell. Um, but oh yes, actually no, I do remember what I was going to say. It has returned to me, the train of thought. There are a number of different catalogs of objects in the sky of objects in the sky, and many objects belong to multiple catalogs. They've been recorded in multiple catalogs. So one of the most popular ones is Messier, so M, and that's what we refer to as objects M101 or M63. And then another catalog is NGC. And it stands for New General Catalog. But for the longest time, oh my gosh, for years, I always thought it meant New Galactic Catalog. And I think that's just infinitely cooler than New General Catalog. And I mean, if I had the power to do so, I would move that we rename the NGC from New General Catalog to New Galactic Catalog. But anyway, those are just my 2 cents.
you know what? I think I was probably thinking of the same thought as well, Sarah, and at one point someone from the RAS clarified it for me, and I was just like, you know what? you are right. Astronomers, they or even scientists, they tend to make their names with cool laws and all of that. But when it comes to catalogs, maybe they're not that very clever on that.
But could you imagine having a star cluster or a group of galaxies named after you? Like, how cool would that be? Oh, incredible, incredible.
Oh, you know what? I think I just did it too much. But yeah, so we're just in the I'm just in the process of fine tuning it, and seeing how things go. And I'm really hoping we'll be able to see this because if not, um,
If not, we can move over to a
yeah,
star cluster for our
I
last
think
image.
I think we may have to start breaking down some lampposts on on
Oh my
Burnaby Mountain.
gosh.
And I'm just kidding. But no, I've usually we're quite lucky with dumbbell. I'm surprised
Yeah.
we're not doing that great.
Yeah. I mean, I don't want to say we were optimistic making this itinerary, but I think galaxies are just not in our cards tonight. Let's try and end on a higher note, and we can move towards one a globular cluster of your choice. How about that?
Okay, that sounds good to me. But before we move, I just want to point out at the dumbbell image that we did take. There was a
Oh
collaborative
yes, of course.
effort. So this was the dumbbell image that was done using the Trottier Observatory. Um, Again, spectacular image. You look through the telescope. It definitely looks something like this as well. But but yeah, and then you know what? I remember this was a lot of, if I remember correctly, sorry, Sarah, this was a lot of cold nights in the observatory as well.
Yeah, I was just about to say. I remember being cramped in that tiny little closet of a command center and taking a picture, and you could only fit at most three people in there with chairs, and you can cram a few more people in there if they're standing. But you're there for the entire night from 9 p.m. till 4 a.m. taking pictures, and everybody gets a little tired, and polite conversation only goes so far. Um, those are long, cold nights, but what ends up happening is that you make some lovely bonds with people.
Yes, absolutely, and you're absolutely correct on that. It was a long nights, but we developed great relationship with our peers and obviously the images that we produce. So yeah, I definitely miss that aspect, but I also prefer being at home and controlling this while I'm at home. So that's also nice.
See, that's the thing is now we can control the observatory from the comfort of our own bed, and while that is lovely, there's really nothing quite like showing up to the observatory, unlocking the door, walking in, powering everything on, feeling a little brisk because you're never going to have the dome warm, of course, because you want it cold and there's a massive hole in the wall so you can look through. But you're sitting in the command center and you turn up the heating all the way, and you're there with your snacks and your food and your tea, and you're sitting there all night taking pictures and quality controlling the images and making sure that the stars are aligned, quite literally, and passing the night like that, and then heading home at 4:35 or whatever first bus comes and leaves SFU. It's There's something really special about those nights.
Yeah, no, absolutely. I absolutely agree with that. I think yeah, I think there were definitely some days where it was we had to kind of discuss and be like, could we like get a bed in there? Is that a possibility, or could we put a sleeping bag in there if
Oh
perhaps we
my
could do that
gosh.
as well?
I
But
think the one design flaw in that building is that there was not enough room in the command center to put a couch because you really get tired, though you shouldn't be sleeping when you're working on it. But if you had two people at the same time working, one person can do a shift of an hour or 2 hours taking pictures, and the other person can nap on the couch. I think that's the one design flaw of that observatory. But other than that, it's quite lovely.
yeah, absolutely. Um, okay, well, I just want to
Oh,
see
beautiful.
if we are able to. Okay, yeah. So I think I'm just looking at it right now, and this might be the clearest we'll be able to get it. So a couple of things about M3 actually. The globular cluster is actually roughly 11. I think it's about 11 or 11.4 billion years old, um, and it's approximately 34,000 light years away. Now this cluster itself it contains approximately 500,000 stars. And I know Sarah gave an excellent description of um, uh, how in globular clusters they are. The closer you get to the center itself, the tighter packed these stars are. And the interesting thing about this one, M3 itself, is that M3 has the most known variable stars than any other known clusters that we right now have, and I think it's about 270 or 274 variable stars that the cluster has, and and it's quite remarkable that an object which is in this case approximately 11 billion years old and how many variable stars it has. So it just shows the evolution process of these objects that we're looking at. Um, and I'm gonna do my best to clear up this image as much as I can, and just bear with me while. Let me see if I can reset the filters a bit, and then we will try to clear this up as much as we can.
Oh, yeah, absolutely. Um, and I'm still quite impressed that you're able to pull out such a beautiful star cluster amid the muggy sky. Also, to keep in mind, in the coming weeks, we will have a meteor shower. We tend to have we do have meteor showers in December and in August. So I believe in the chat, Haley mentioned has said that the meteor shower, Perseid meteor shower, will peak August 12th at around 10:30 p.m. So do take a moment to lay outside and observe the sky if you can, if it's a clear night. It's quite lovely to see the stars streak across the sky.
Yeah, I think it's been a while since I've seen a proper meteor shower. The last couple I've been to, one of them it started raining, one of them it got
Oh,
cloudy, and the other one I saw maybe about 15, I would say, before the mosquitoes started attacking me, and I called it a night. So,
well, that's the thing is this: the summer meteor showers are lovely because you have warmth compared to the winter ones, but then you get the mosquitoes, and then the winter ones are a little bit tricky because it's cold as heck. Um, but there are no mosquitoes.
yes, absolutely. Um, yeah, I apologize again. I don't think we're getting any clearer today. Um, and again, it's a lot to do with atmosphere, and it's a lot to do with where the observatory sits as well. Um, but I just wanted to see if Sarah, if there's something else we wanted to talk about or discuss. Um,
No, I
I
think
know
we've
we
hit
are over time
everything
now.
that we intended to or tried to.
Yeah, absolutely. And again, I think it's the galaxies that kind of we weren't able to hit, but yeah. One thing I just wanted to remind everyone, if there are individuals in the audience who are part of the who are sorry, they need those stamps for the loyalty for the telescope loyalty program. Please remember to email SFU Science Outreach to receive credit for attending today's SFU Starry Nights.
Absolutely. So when you do email SFU's, I think I'll put the email address in the chat. But when you email to let them know that you watched tonight's Starry Nights, make sure to list a few of the objects that we talked about, because we will, or that we tried to look at least, and then. And then you will be able to get credit for your stamp, because we will release this video, the recorded video, in 24 hours time to allow for people who were here live to claim the evidence that they were here. So
Yeah.
thank you everybody for participating and supporting Starry Nights.
Yeah, thanks everyone, and I think we are over time now. So at this point, I just wanted to thank all of the moderators that are here. So thank you to Lee, Haley, Zena, Zach, and if I did miss someone, I do apologize. And Zena, any closing thoughts before we call it a night?
Zena. Oh,
Oh, I'm sorry. I'm
you
so
mean
sorry,
Sarah.
Sarah. My
Sorry.
apologies.
It's okay. No worries. I got a little confused. No, I have no closing thoughts. Thank you everybody for joining us. We really appreciate you coming out and watching it. It brings a lot of light, the great kind of light into our skies.
Thank you so much, Sarah. And there will be a Starry Nights again next week as well, weather permitting. So watch out for notifications for that one. And once again, thank you everyone for coming, and have a great evening.
Stay safe.